everyone. My name is Renee Long, a communication specialist and webinar coordinator here at ACHS. Joining me today behind the scenes for all our technical needs is Dominic Aiello, a social media specialist and webinar coordinator here at ACHS. And today we'll be hosting a webinar from our Master Lecture Series. Each of these webinars features an expert in the holistic health field from the ACHS faculty. And it's my pleasure today to welcome you to today's Master Lecture webinar, The Amazing Actions of Antioxidants, presented by ACHS faculty member Brandy Ferrara. Just a few housekeeping items before we get started. You may have noticed that your line has been muted. We're recording today's webinar, and this ensures we can clearly hear our presenter. You'll also notice that you have a control panel at the right-hand side of your screen. If you have a question for Dr. Ferrara during the webinar, go ahead and type it in the questions box, and she will read and answer them during the 10-minute Q&A session at the end of the webinar. If you have further questions that require a bit more depth of answer, please feel free to follow up with Dr. Ferrara directly at brandyferrara@achs.edu, and I'll spell that out for you. It's BrandyFerrara@achs.edu, and we'll have that up on the screen later on. She's happy to respond to all your questions, but please be sure to give her some time to get back to you. And now I'll go ahead and turn the webinar over to Dr. Ferrara, who will give a brief introduction and then begin her lecture.
Everyone, thanks a lot for joining me in this presentation. During the next hour or so, I'll be talking about antioxidants and how they're working in the body. So you can really tell from this presentation how amazing antioxidants really are. I'll give a brief introduction of myself. I am a doctor of chiropractic medicine, and I graduated in 2007 from the National University of Health Sciences, and that's in Illinois. And after that, pretty much directly after that, I started a Master's of Science in Human Nutrition, and that was from the University of Bridgeport, and I completed that in 2009. Since 2014, I've been an adjunct faculty member at the American College of Healthcare Sciences, and I've really been having a lot of fun. The students are amazing, the courses are amazing, and the support for the college that is offered to us is really amazing, so I appreciate all of that. So with my background with Master's in Human Nutrition and being a doctor of chiropractic, I teach a lot of nutrition courses, both graduate and undergraduate, in anatomy and physiology. Those are two of my main focuses. So I'd like to get started by, giving a brief introduction about what an antioxidant is and explaining what a free radical is. A lot of times these terms are used and, it may or may not be very clear, so I'd like to define those for the attendees. So an antioxidant really is a substance that's going to be protecting the body from free radicals that we have. Now, when you're thinking about what a free radical is, and there'll be some examples that are coming up later on, but we want to make sure that we understand what that is, so we'll define that. And really all that is an atom or a molecule. It has a single unpaired electron in its outer shell. So if you can remember back from chemistry days, imagining those orbitals around the nucleus, the center of the atom, we're going to have an unpaired electrons in that outermost shell. Really, a lot of these free radicals are highly reactive and they're very unstable. So what they're essentially trying to do is they're looking for these electrons to make themselves more stable molecules. And because of this, because they're looking for these electrons to fill that outer valence shell, they damage cells. So when you're thinking about what this actually does to the human body, they're doing this damage to these cells, it can really accelerate the progression of diseases in the body. Some cancers are associated with having high amounts of free radicals or damage to free radicals, cardiovascular disease, and some age-related diseases as well. So essentially what antioxidants are doing is they're going to work by donating electrons to free radicals to help them become more stable. There are quite a few antioxidants that we have, and we'll be covering a few of them today. But some of the examples that we have of antioxidants are vitamin C, vitamin E, selenium is another one. Coenzyme Q or CoQ10, another name for the same molecule. Carotenoids, ceruloplasmin, flavonoids, glutathione, and taurine. These are all antioxidants. But because of time, today we're just going to discuss a few. Vitamin C and E we'll be spending some time on, as well as selenium, coenzyme Q, carotenoids, and glutathione is what we'll be talking about today. So here's a picture that helps to emphasize how these antioxidants are working. On this first square, you can see a normal oxygen atom. And in this molecule, we're seeing that it's going to be losing an electron. And what this is doing is it creates then a free radical because there's an unpaired electron in that outer shell. Now, this free radical that's formed is going to be setting off a chain reaction. So that molecule is going to be searching for electrons to help to neutralize that molecule, to make it more stable. So it's going to be stealing electrons from a nearby cell. And this is essentially going to be creating a chain reactions of stealing these electrons to make whatever was beforehand more stable. And it's really pretty chaotic, and ultimately this ends up in resulting in disease. So as this molecule is doing its damage, it starts this erosion of the cell membrane, and this is where we can really start to see that chronic disease is occurring. So if an antioxidant is present, it will help to neutralize that free radical by donating an electron. And hopefully this will stop that damaging chain reaction from continuing to have to create damage in the body. So I like this picture because it really just shows everything that we have. You know, we've got different types of learners. We've got audio learners and we've got visual learners, and this I think will help with the visual learners that we have out there. So let's again just kind of like make sure that we really understand what a free radical is. So we'll cover a little bit of that free radical chemistry. So these free radicals, again, when you're just looking at chemistry and what we have in atoms, remember all the way back from your basic chemistry classes that atoms are going to be containing protons, neutrons, and electrons. Now, these electrons that we have in the atoms, they're revolving in orbitals around the nucleus. And, you know, one way that I kind of always like to describe it, if you think of Saturn with the ring around it, if you want to picture that. So we've got these electrons that would essentially be found in the ring outside of Saturn, which you could be representing the nucleus. And these electrons that are found in those orbitals are generally found in pairs. Now, when we're thinking about a free radical, this is going to have that unpaired electrons in that outer shell. And because of that, we have a very highly reactive molecule. So let's consider a specific type of free radical that we're going to be calling a reactive oxygen species. Now, a reactive oxygen species is really just a chemically reactive molecule, a free radical that contains oxygen. These are really formed as a natural byproduct of the normal metabolism of oxygen, and they're formed during exposure to some substances and also to physiological processes. Smog, ozone, drugs, these are some substances in the environment when we're exposed to them that could cause, that could create these reactive oxygen species or ROs. Now, when you're considering these reactive oxygen species, and we're going to actually be talking about how we can eliminate each one of these are the examples that we're going to be including in this presentation. So superoxide radical, that's an example of a reactive oxygen species. Hydrogen peroxide, hydroxyl radical, Also carbon-centered or peroxyl and hydrogen peroxyl radicals, and also lipid peroxides. These are all reactive oxygen species and singlet molecular oxygen. So as we go through this presentation, again, we'll talk about how antioxidants, those antioxidants that I referred to in slide 3, those specific examples, how they're going to be playing a role in the elimination of each one of these reactive oxygen species. So really, these antioxidants will do us a huge service by taking care of these free radicals. So what we have is the damage that's being created by these reactive species. So free radicals are going to attack. They're going to be attacking the cells that are surrounding them. They're going to be attacking the cell constituents that we find, like the mitochondria, endoplasmic reticulum. They can also attack the proteins, polysaccharides, the nucleus. And really what they're doing is they're creating this damage, and that we can see that will result in some chronic diseases later on. And when we have a free radical, it really gives rise to more free radicals and more damage occurring. So antioxidants are going to help to make sure that this doesn't become that chain reaction that I showed on that previous slide. So let's now consider the antioxidant nutrients and their functions. So overproduction of reactive oxygen and also nitrogen species, just basically a free radical, a chemically reactive molecule that contains nitrogen as opposed to oxygen. So both of these species can put an attack on DNA, on proteins, and also on polyunsaturated fatty acids. And these really have been implicated as a contributor to a lot of conditions that we've kind of already introduced: cancer, cardiovascular disease, cataracts, which is an age-related complication, or complications of diabetes mellitus, like loss of a lower limb, or kidney failure, blindness. Those are complications of diabetes mellitus. So these antioxidant compounds are going to function to help to control or eliminate these free radicals. That's the function of how they're going to be working in the body. The primary mechanism by which the body gets rid of some of these reactive oxygen species is where we're going to be turning our focus on to next. So the first one, and I'm just going to backtrack so you can see the list that we have on the screen again. Each one of these reactive oxygen species is what we're going to be talking about next, and how we can actually eliminate them by the use of antioxidants. So I'm going to go forward to these slides, and the first one that we're going to be talking about is the elimination of superoxide radicals. So really how we're going to be getting rid of superoxide radicals is the conversion of superoxide radicals to other compounds. Several antioxidant nutrients are going to be functioning to dispose of these superoxide radicals. These nutrients include vitamin C, and then we've also got a few minerals that are going to be helping out: zinc, copper, and manganese. And these are going to be functioning as cofactors for enzymes involved in oxidant defense. Vitamin C, or ascorbate, can help to provide electrons to reduce superoxide radical to then form hydrogen peroxide and dehydroascorbate. So if you're looking at this picture here, here is our structure, our chemical formation of ascorbate, and we're going to be taking our superoxide radical, and what we end up with is going to be hydrogen peroxide and dihydroascorbate. Now, this elimination of superoxide radicals can also be done by the action of an enzyme called superoxide dismutase, or SOD is another term that people typically call this enzyme. Superoxide dismutase works faster than vitamin C in the deactivation of superoxide radicals, so it is going to be helpful in getting rid of the superoxide radicals. And this enzyme is going to be dependent on the presence of zinc and copper and manganese. Really, zinc and copper when we're talking about this occurring extracellularly, so outside of the cell, and manganese when this is occurring intracellularly inside the mitochondria. And in this picture here, you can see how the enzyme is going to be taking our superoxide radicals and helping to form our hydrogen peroxide as well as molecular oxygen. Now we'll turn our focus to the elimination of hydrogen peroxide. Vitamin C readily reacts with hydrogen peroxide as well as some other enzymes like glutathione peroxidase and catalase. Those are two of the enzymes that we have. Vitamin C is really good at scavenging hydrogen peroxide. So what happens is the ascorbate reacts with hydrogen peroxide, and this is going to be producing water and dihydroascorbate. And that's what we see in this picture here. Ascorbate reacting with hydrogen peroxide, and we end up with 2 molecules of water and dihydroascorbate, effectively eliminating that hydrogen peroxide. When we're looking at the enzyme glutathione peroxidase, this one is going to be requiring selenium as a cofactor. So this is really an enzyme that's necessary not only for the removal of hydrogen peroxide, but also for the reduction of other peroxides. Again, it does require selenium. And if there is a poor status of selenium or of iron, the activity of this enzyme is really going to be impaired. So this reaction catalyzed by glutathione peroxidase for hydrogen peroxide removal requires tripeptide glutathione in its reduced form. And you see that what we end up with is going to be the oxidized form of glutathione and 2 molecules of water. Catalase, that other enzyme that was mentioned, is another enzyme that's going to be involved in the removal of hydrogen peroxide. And this enzyme is going to be dependent on heme iron. So that is going to be something that's going to be necessary. Now, higher concentrations of hydrogen peroxide are going to be required for catalase activity. And this is going to be higher than what we would see if we were having the other enzyme being active, glutathione peroxidase. So here's that enzyme doing its job on hydrogen peroxide. Now we end up with 2 molecules of water and molecular oxygen. We'll next turn our focus to the elimination of hydroxyl radicals, another one of those ROSs that we need to get rid of. So vitamin C is going to be helping with the elimination here, and this is going to be reacting with those hydroxyl radicals to produce water and a less reactive semi-dihydroascorbate radical. Now later on we'll address some of these other issues that we have, but let's just first talk about the elimination of these Glutathione can also act directly with hydroxyl radicals. So we see here we've got our glutathione, and that's working with our hydroxyl radicals to help to eliminate that, and we end up with water as well. Now we'll turn our focus to the elimination of a lot of the ROSs, carbon-centered, peroxyl, and hydroperoxyl radicals, as well as lipid peroxides. Well, there are a lot of nutrients and compounds that are actively going to be working on these ROSs. Vitamin E is going to be one of them, carotenoids, manganese, ubiquinol or coenzyme, vitamin C, glutathione, as well as the selenium-dependent enzyme, glutathione peroxidase. These are really going to be actively eliminating each one of these ROSs, these carbon-centered peroxyl and hydroperoxyl radicals, as well as that lipid peroxides. So in each one of these examples, we'll show you how the antioxidant is going to be working on that particular ROS. So in this first example here, vitamin E, depicted here with the EH, is going to be terminating the carbon-centered radical before they extract further hydrogens from other polyunsaturated fats. So that's what we're seeing in this first example. In our next example, vitamin E prevents perioxidation of polyunsaturated fatty acids by reacting with peroxyl radicals. And essentially what we're seeing here is that vitamin E is going to be terminating chain propagation reactions, which is a good thing. We want to make sure that we don't have this chain reaction occurring, and we can actually stop this before damage or too much damage occurs to the cells or the constituents of the cells or to proteins or polyunsaturated fatty acids. Another example of an antioxidant working with this group of ROSs is carotenoids. Carotenoids have the ability to react directly with peroxyl radicals involved in lipid perioxidation. So this is really going to be carried out to a lesser extent than vitamin E, so it doesn't have as much of a role in the body. But our carotenoids, like beta-carotene, are considered to be antioxidants. Some of the transitional metals, like manganese, they also are able to scavenge peroxyl radicals, and that's what we're seeing in this example, where manganese is actually going to be donating an electron to these peroxide radicals, and we're going to have a reduced form, which is going to be less reactive. In addition to vitamin E and the carotenoids and manganese, ubiquinol can also provide hydrogens to terminate the peroxyl radicals. And these are potent antioxidants. So ubiquinol, you probably also have heard that as coenzyme Q10 or CoQ10 is usually how I say it. This is going to be found in small quantities in lipoproteins. And here it's thought to be utilized before vitamin E in the termination of these peroxide radicals. And that is what we're seeing in this reaction. Vitamin C can effectively scavenge these achs and peroxide radicals. And this is what we're seeing in this next slide, how ascorbate, vitamin C, can also help with these radicals. Now, both ascorbate, and this is what we're going to see in this next reaction. So both ascorbate and ascorbate radical, these can react with these peroxide radicals to produce a lipid peroxide and the ascorbate radical, or dehydroascorbate, depending on which one we're talking about. So in this first example, we have ascorbate working with a peroxyl radical, and what we end up getting is going to be something that's going to be less reactive on the other side, ascorbate radical. We can also see in the reaction underneath that we have these ascorbate radical, and we're going to end up producing dehydroascorbate on the other side of the reaction. Again, we've got a reduced form, so these are going to be less reactive, doing less damage. They're in a more stable molecular structure. Glutathione and selenium-dependent enzyme glutathione peroxidase also are going to be functioning in the elimination of lipid peroxidases. So glutathione peroxidase, as we see right here, is going to be using glutathione in its reduced form, and this helps that reaction or catalyzes that conversion of the peroxidases to our hydroxyl acids. And we get some water in this reaction, and also what you see on the other side of this reaction is that oxidized glutathione as well. The last ROS that we want to talk about being eliminated by antioxidants is the singlet molecular oxygen. So carotenoids can actually quench the singlet molecular oxygen. And just to give a definition, what we mean by quenching is this process where electrically excited molecules are inactivated. And that's a good thing. That's what we want. So the carotenoids can absorb energy from the singlet oxygen without chemical change. And this is going to return the excited singlet molecular oxygen to its ground state. So it's not going to be reactive. The carotenoids then release the energy in the form of heat, and they don't need to be regenerated because of this. We're releasing heat, we're releasing energy in the form of heat, and in this way we're effectively bringing that excited level down. So it's kind of a neat way to eliminate one of the ROSs. So those were each of the ROSs that I wanted to show you the elimination of by using these antioxidants. But it's also important to keep in mind that as we're using these antioxidants to eliminate these free radicals or reactive oxygen species, the ROSs, we want to regenerate those antioxidants. And really that's important to prevent further damage against any of the free radicals. If you can take an example, you want to think of like vitamin E for an example. So for if you're looking at about 1 to 2,000 unsaturated fatty acids in the cell membrane, phospholipids, you can see that there are fewer than 9 vitamin E molecules that would help with those 1 to 2,000 unsaturated fatty acids. So we do want regeneration of these antioxidants. We want to recycle them so that these vitamins and these compounds can be used again and regain their antioxidant function. So in the next few slides, we're going to be looking at how a few of these antioxidants are going to be regenerated. And the first one that we're going to be looking at is vitamin E. The regeneration of vitamin E is thought to require migration of the vitamin to the membrane of the surface of the membrane, and it's here that we're going to be seeing a lot of compounds aid in this regeneration of vitamin E. Ascorbate is one of them, ubiquitol is another, and glutathione. These can all help to regenerate vitamin E. So that's what we're seeing in each one of these examples. Here we have ascorbate that's going to be donating that hydrogen so that we have our alpha tocopherol being reformed. So ascorbate in this example can regenerate that alpha tocopherol from its radical form. That's what we see with the E and the superscript dot. And in this process, that ascorbate now becomes radical itself. That needs to be regenerated, and we'll talk about that when we talk about the regeneration of vitamin C. In this example here, we have the ubiquitol to help to function in that recycling of vitamin C. And also in this example, we have glutathione in its reduced form in helping to donate hydrogen atoms to reform vitamin E. So in each one of these examples, we can see that we can actually regenerate vitamin E so that it can continue to have its antioxidant functions. Ubiquitol is another antioxidant that we would like to regenerate, and the regeneration of vitamin E, which we had just shown by ubiquitol, is going to be resulting in the formation of ubisemiquinone. Ubisemiquinone can be converted back to ubiquitol by dihydrolipoic acid, and that's what we're showing here. So we get that regeneration of ubiquitol with the help of a couple of other molecules in the body. And in this way, ubiquitol can continue to go out and do its job. Vitamin C is another one of the antioxidants that we want to regenerate. And niacin is going to be assisting with this. So niacin, in its coenzyme form, NADH, is going to be allowing for that regeneration of vitamin C. And that's what we're seeing in this example here, our radical form of ascorbate. By using that coenzyme, we're going to be getting our regeneration of ascorbate, and now we have our oxidized form of the coenzyme left over, which is fine. That has other functions in the body. If you remember the cellular respiration, we'll be able to use that in other areas of the body. Glutathione regeneration is our next antioxidant that we want to talk about how we're going to be regenerating. So glutathione reductase is going to be functioning to regenerate oxidized glutathione. And here we're going to be requiring FAD as the cofactor. So this is a nice quick little step where we're going to be using an enzyme to help to regenerate that glutathione, again in its reduced form. So it's really neat how the body uses these antioxidants both to eliminate these free radicals or ROSs, but then also we have enzymes and other compounds in the body that can help to bring back these antioxidants so that we can continue to use them. And that really is important because overproduction of these reactive species, these free radicals, is thought to contribute to aging and the development of several diseases. We've briefly mentioned these before. Some cancers are associated with the overproduction of free radicals. Heart disease, cataracts, complications from diabetes mellitus, like cardiovascular disease, like kidney disease, like loss of a lower limb. All of those could be complications of diabetes mellitus, and also ischemia reperfusion injury. Ischemia reperfusion injury is really just that injury that we see, that damage that we see to tissue when that blood supply comes back to the tissue after a period of time where there wasn't oxygen being brought to that tissue, so during ischemia. Now, there are a lot of studies that have shown that individuals who consume diets rich in foods containing antioxidant nutrients do have a lower risk of many of these diseases mentioned above, but it is important to also note that there have been studies that show that supplementation can help, but they are pretty inconsistent, so when you're considering supplements, consider your source, and never take out the potential effect of what you could see with the synergistic relationship between the phytochemicals or the zoochemicals and any one of these antioxidants. There's nothing that we can do to duplicate or replicate what we see in nature. So I'm a big proponent and believer in whole foods as your sources for antioxidants. So let's look at where we can get some of these antioxidants in our food. So vitamin C, I think that most of you know some good sources of vitamin C, but just as a reminder, acerola berries are going to be good. These are from Central and South America. Oranges, or really basically all of your citrus fruits, grapefruit, all of these are going to be great sources of vitamin C. Guava, peppers, kiwi, Brussels sprouts, and generally green vegetables are going to be good sources of vitamin C. Cauliflower, mango. And when you're considering how much you need to take, the RDA is considered to be 60 milligrams every day. For smokers, that is, the RDA does go up. And there has been some research that shows that athletes would need more of vitamin C and just in general more antioxidants because of the oxidative damage that we're seeing. Food sources of vitamin E, which is another fantastic antioxidant, would be wheat germ oil, basically a lot of your vegetable oils. Sunflower seeds, almonds, and pecans are also really good sources. Sunflower oil, again, your vegetable oils. Sweet potato, flax oil, cauliflower oil, avocado. All really great sources of vitamin E. And the RDA for vitamin E is 1,000 milligrams every day. Now this is going to be your fat-soluble vitamin, so you get a little bit more leniency on the amount that you get every day with vitamin E. And I'm going to backtrack to the previous slide. Vitamin C, as you recall, is a water-soluble vitamin, so that one you really should try to meet that daily requirement every day. It's water-soluble, so you need to make sure that you bring that in daily. It's not stored as well as vitamin E, if at all. Other great antioxidants that we have, selenium and the carotenoids. So these are some food sources that we have in selenium, for selenium. Brazil nuts are a great source of selenium. Snapper, halibut, salmon, and scallops, all of these are really good sources. Swiss chard and oats. Oyster and wheat germ are all really good sources of selenium. And the RDA for selenium is 55 to 70 micrograms per day, so that's a much smaller amount than our milligram amount that we saw with our vitamins in the previous two slides. And then our carotenoids that we have, these are really coming from a lot of your red, green, and orange vegetables. So things like carrots, sweet potatoes, your dark leafy greens, kale, Swiss chard, tomatoes. All of these are really good sources of the carotenoids. And the RDA for this is between 2 and 4 milligrams every day. Glutathione, one of the other antioxidants that we have, is going to be coming from a lot of your sulfur-rich foods. So foods like garlic or onions, or your cruciferous vegetables like bok choy, broccoli, cabbage, cauliflower, Brussels sprouts, those all are found in that cruciferous vegetable family. All are these sulfur-rich foods, and all of them are really great sources of glutathione. On this slide, I have my references, so you can go back and look at any of these references. One of my all-time favorite books is the Medical Nutrition from Mars. I believe that this is out of print now, so if you are looking around for that book, I don't think that they're printing that one anymore. And now I'd like to open this up for any questions that you may have.
Hi, Brandy. We do have a couple questions, so we're just going to send them to you through the chat box, and you can see if you can expand your chat box.
So I did get the question on for smokers and the increased amount needed for vitamin C. Typically, they're saying that's about 100 milligrams a day then. So this is in regards to if antioxidants truly prevent cancer diseases. Has this really been proven? There is research out there that has a strong support that when taken so if you have a diet that's really rich in these foods, a diet that's rich in the foods that contain these antioxidants, there is going to be a lower risk of these diseases or these conditions. Now, the association is what they're kind of trying to tease out yet, because generally people who eat a lot of these foods also live a healthier lifestyle. So it is hard to, if you can imagine, pick out the one thing that's going to be the preventer, because a healthy lifestyle includes a lot of different things: minimal alcohol consumption, active lifestyle, so both being physically active and exercising on top of that, and just generally avoiding a lot of foods with trans fats or are bad fats, eating foods with less refined sugars and so forth. So that's what I mean by a whole healthy lifestyle. These foods are generally incorporated into that. It is definitely hard to say that this is the one factor that is the contributing factor for preventing those cancers and these diseases or helping to reduce those risks, but they are thinking that this is definitely a contributing factor. That was kind of lengthy. Another question that we have. I have a question about those who are intolerant to sulfur, and is there another good source of glutathione? Sorry, that was kind of broken up a little bit. So other sources of glutathione, you could consider supplementation. That would be another fine way to get that. You kind of consider, you want to think about taking in whole foods. So I'm trying to rack my brain and think about good sources of glutathione. A lot of the animals from those amino acids would be the sulfur containing amino acids. Fungi could also be a source, but yeah, I guess my question would be maybe what reaction to the sulfur is, and then maybe going with if it's a very severe reaction, then supplementation might be the only way. Like if it's something that is life-threatening, which I doubt it because this is something that we have in the body, or if it's more of just a discomfort. So I guess I had a follow-up question on that. Another question I have Is juicing a better way of getting these antioxidants into our bodies? I do like juicing for small periods of time. It depends on how the juicing is done. A lot of times juicing is getting rid of the fiber. So how I typically juice or get a lot of fruits and vegetables in is I just grind everything up in a food processor, put in some extra water, and now I have a fruit and vegetable smoothie. It's a great way to get a lot of the antioxidants in, but any whole foods that you're taking in is really just going to be a great way. So fresh fruits and vegetables. If you can't get fresh, then freshly frozen. I have another question here. Selenium sources are found to be low in Oregon. Same thing in Wisconsin. Our soil is not very rich in selenium, and this is a mineral that is picked up by the plants, and the plants will display the amount of selenium of the soil that they were grown in. So definitely, yeah, if you're buying locally, a supplement, if buying local sources of food, a supplement is going to be best. Should selenium and glutathione be taken together? They could, but as long as you're doing this within the day, meeting the daily requirements, you should be okay. Other question I have, kind of oats to be included for selenium. Again, because selenium is taken up by the plant, and the amount of selenium that's found there is going to be found in the soil, is going to be what's displayed in that plant. But my best oat is always going to be steel cut, mostly just for the better um, source of nutrients from the steel oats. Another question that I have is which whole food supplements would you recommend for the best antioxidant effects? Is that okay to answer?
Sure.
Okay.
Yeah, go ahead.
I wasn't sure if that would be like promoting one brand. Personally, I like Standard Process, but that's one that I've used, and both for myself and for my family, and as I was an intern in chiropractic school, Standard Process was one of the ones that I used quite often. I just wanted to make sure I wasn't like
No, you're fine.
promoting anything that.
Yeah. No, it's on,
I'm
yeah,
not trying to sell anything.
right. Everybody knows we're not affiliated, and that she's just, that's what she uses, and yeah.
Mm-hmm. Oh, next question. If antioxidants are consumed once the diseases are diagnosed, will the disease become less present? Good question. It really just depends on where that disease state is. There could be some lessened signs of disease. Was that exactly because of the antioxidant, or was it because of the better lifestyle that was being displayed? Again, that's hard to kind of tease out, but definitely a healthier lifestyle will help that disease and those symptoms become less. But there is definitely a point in the disease state where it's irreversible, and that varies from disease to disease. Oh, okay. I have that answer from the question that I had before, the sulfur bloating and gas. So this may be a problem with the cruciferous vegetables, possibly. So You may want to try to take something like a anti-gas around the same time, depending on how uncomfortable it is, may help. Again, are antioxidants effective once someone has been diagnosed with cancer? Again, depending on what stage of cancer you're in, they will definitely help to slow that progression. The mutation is what's occurring with cancer. So what the goal is to slow the progression of the cancer. Could it help it to completely disappear? Well, we've all got cancer in our body all the time. It's just mutation of these cells. It just depends on how out of control it's getting. Definitely, diet rich in antioxidants is going to be important during the recovery process. And I have another question about Shratorium dietary supplement. I have not heard about that. So that would be something, if you wouldn't mind shooting me an email. The address is going to be coming up on the next slide, I think, my email address, Brandy Ferrara at achs.edu, and I can look into that dietary supplement. Next question, how important is food combining and healthy fats for absorbing vitamins to gain the benefits of these antioxidants? Very important. There's going to be substances like phytic acid that may decrease absorption. And healthy fats are going to be important, especially when you're considering the absorption of any of the fat-soluble vitamins. You need those to absorb those vitamins across the membrane of the small intestine. So yeah, you do want to bring in anything that's going to be helping with absorption, and then making sure that you're avoiding anything that isn't going to be competing for the absorption. Another question, should people already diagnosed with cancer take antioxidant supplements? I just am leery of this because I don't want to get into giving recommendations. So I would say go with the physician's recommendation, whoever the oncologist is. Is that safe to say, Renee?
Yeah, I think that's fine.
Okay.
I actually had a question myself. I had heard growing up that eating or having milk or dairy with an antioxidant-rich food actually cancels out the antioxidants. Is that true?
That one, Renee, I haven't heard of. I am not sure what the component of the dairy would be.
Yeah, maybe an enzyme or something.
Yeah, because when you're talking about
the
what was that?
It could just be an urban legend as well.
Yeah, sometimes those.
Yeah, I think one of the examples was milk chocolate versus dark chocolate.
Oh, okay. Yeah, dark chocolate does have a good phytochemical in it. But that one, you know what? If you wouldn't mind, Renee, shooting me an email and I'll look into it. I just I would hate to give an answer thinking about it without knowing exactly why.
Definitely.
Like
an interesting topic. Yeah.
Yeah. What exactly that component would be. Another question, is there any research connecting antioxidants in helping with arthritis? There are a bunch of different types of arthritis. Inflammation, antioxidants will definitely help with any inflammatory diseases that we have.
I think we have time for one more question.
Okay.
You want to choose one
Cooking
from the box?
destroy any of the antioxidants? When you're looking at destruction of antioxidants, you would consider more your water-soluble vitamins. That would be the biggest effect that we have. Now, like vitamin C, if you're considering your antioxidant, one thing that we always used to do with our girls when we made their food, when they're infants, and we would uh, puree their food. Let's say if we made them pureed carrots or something like that, we would save some of that water and put that in with the cooked carrots to help to bring a little bit of that back. But yeah, it's your water-soluble vitamins that would have the most destruction.
That's great. I was wondering that too, so that was a great question. So that is about all the time that we have. Thank you so much, everybody, for joining us on this webinar. And thank you so much, Dr. Ferrara, for coming and giving that wonderful lecture. I feel like I really learned a lot myself. And if anybody has any follow-up questions, there were a few of you I think that we didn't get to, but we'd love to answer your questions. If you want to email Dr. Ferrara at brandyferrara@achs.edu, and that is in the chat box there. And thanks again, everybody, for attending our master lecture. And definitely keep an eye out for an email, which we'll send out soon with a free recording of today's webinar. And also stay subscribed to the ACHS webinar email list so you can receive future announcements and invites to our master lecture series. And if you enjoy the content of today's webinar, you're sure to enjoy the knowledge you'll gain in our accredited online course, NAT 101, Nutrition, Body Care, and Herbalism Online, which focuses on complementary alternative medicine aspects of nutrition, such as whole foods, raw foods, and organic foods, in addition to giving an overview of macronutrients and micronutrients. And it discusses a wellness lifestyle program that includes some information on life stages. Additional module topics include herbal medicine, holistic body care, energetic modalities, such as homeopathy and flower essences, and aromatherapy. If you're interested in learning more, just use the links on your screen, that should be up soon, to get in touch with one of our savvy admissions advisors. So thanks again, everyone, and have a wonderful day, and thank you so much, Dr. Ferrara.
You're welcome. Thanks, everyone who attended. I really appreciate it.